All right, so these are the Keystone practice problems. And my whole job is not to teach you just how to do these mathematically, but it's to teach you how to do them quickly and efficiently. So first step, when doing any of these problems, read the problem first, look at your answers. All right, it says Jenny has a job that pays her $8 per hour, all right, plus tips, which is T. Jenny worked for 4 hours on Monday and made $65 in all. Which equation could be used to find the amount Jenny made in tips? Now, it says $8 per hour. Okay, so I'm looking down here, it says 65 equals 4T plus 8. Well, okay, T was tips and 4 was hours. So that doesn't really make sense to me why I would be multiplying my 4 hours times tips. So I'm already kind of believing that A is not my answer. Now B says 65 equals 8T divided by 4. Well, why would I divide by my tips? That doesn't make sense. So I'm going to cross off B because that doesn't make sense to me. There we go. Sorry, I'm going to have to align this board. So, all right, so I'm going to cross off B. Now it says C, 65 equals 8, which is my dollars per hour, times T, that's my tips, okay, plus 4. Well, why would I add 4 hours at the end? That doesn't make sense to me. So I'm going to cross that out. Now D says 65 equals 8, which was my dollars per hour, times 4, which is the number of hours I worked, plus my tips. Well, guess what? I'm feeling my answer is D and not A. Now, why is it D and not A? Well, if you're making $8 an hour and you work for 4 hours, okay, you're going to do your rate, like your wage times the number of hours you worked plus your tips, okay? And that's where it comes from. Is everybody okay with number 1? All right, number 2. Number 2 says, in an experiment, a plant grows 0.05 centimeters per day. Okay, the plant had a height of 2 centimeters when the experiment began. Which equation describes the relationship between the number of days, D, the experiment lasts, and the height aged in centimeters? Okay, so well, let's think about this. Now, I could read through just like I did in number 1 and look and see which one makes sense. But if we go just slightly more mathematical, this word per, does everybody see that word per right there that I tried to underline? All right, that word per kind of means like multiply. So I have 0.05, that's the centimeters, all right, per day. D is day. So I have 0.05 times the number of days, and the plant started at 2 centimeters. So now once I have that, I can look at my equations and see, well, it's not B, it's not C, and it's not D. So my answer was A. All right, while I align my board, I want you guys to read number 3. All right, does anybody think they have the answer to number 3? What about Jordan? Do you think you have the answer to Keyshawn?
No, I don't have it yet.
Okay. Do you know where to start with this problem? It's okay to say no. Jordan, you want some help?
Yeah, probably.
So Jordan, it says Keyshawn buys 100 baseball cards to start a collection. He purchases 25 more baseball cards each week. So he adds to his collection 25 cards per week, which is W. Okay? Which equation could be used to represent the number of baseball cards B in Keyshawn's collection after W weeks? What about now, Jordan? Which one do you think it is now? A, B, C, or D, Jordan? All right, what about Emma? Which one would it be?
A.
Well, I see where you're going with A, but are my variables in the right place with A, Emma?
Oh, wait.
So that's the distractor here. Notice in A, they switched, right? They switched the W and the B, correct?
Yeah.
You see how the 25 is partnered with the W? So
Does
my
that mean it's C?
C. There you go. So don't fall for the distractor. Make sure you look at your questions carefully. A person's hair is 8 centimeters long. Okay? And it says the equation below can be used to estimate the length in centimeters, all right, that the person's hair will be after W weeks. So they gave you L equals W divided by 4 plus 8. Based on the equation, what will the estimated length of the person's hair after 10 weeks be? Liam, where do I put the 10 in? Do I put it in for L or W? Liam?
The L.
Well, what does 10 represent? Does it represent length or weeks?
Weeks.
So it's going to go in for W. Now, do you have a calculator, Liam?
Not with me now.
You can pull one up, okay? And then once you do, can you do 10 divided by 4 plus 8? What did you get, Liam?
10.5.
There you go. So this one we actually had to solve out. All right, let's turn the page. Nate, Miss Bernard monitored the growth of a fish. The fish was originally weighed in at 27 ounces. The fish grew at a rate of 5 ounces per month. The equation below can be used to describe the weight in ounces of the fish. Mrs. Bernard correctly determined that x equals 9. What does the solution of the equation mean? Do you have any idea, Nate?
No.
What was that?
Not really, no.
Okay. Well, let's look at this. The 72 represents how much the fish weighs now, correct? The 27 represents how much the fish started out at. Okay? Now, notice, do you see, Nate, that the 5 right there says 5 ounces per month. So what do you think X represents?
How many months?
Month.
5 ounces.
So which one of my answers relates the 9 to months? A, B, C, or D? You could eliminate it down to 2 answers. Which 2 can you get rid of, Nate?
A
Would
and
you
B.
agree we can get rid of A?
Yeah.
Yeah, we can get rid of A.
Would it be C?
It would be C. Now it's C because the fish is not growing at a rate of 72 ounces per month. In the problem, it clearly states that it's growing at 5 ounces per month. So that's why I can get rid of that one. And then D says it took 72 months for the fish to grow 9 ounces. Well, it didn't. It took 9 months. So the answer is C. Sylvia studied a new language. The equation below describes how many words she knew. Y after studying the language for X days. The ordered pair 6, 48 is a solution to the equation. What does this solution represent? Well, this is actually a lot easier than you think. Now, 648. This is X and this is Y. Y represents how many words she knew. Okay? So this is words known. And the 6 right there says days. So now let's look at our answers. It says Sylvia knew 6 words. Well, that's not true because 6 corresponds to days. Well, B is off the table now because it also says 6 words. Now it says Sylvia knew 48 words after 6 days. Okay, maybe. Sylvia knew 48 words after 48 days. Well, that doesn't make sense because days is 6. So the answer has to be C. And that's just because I knew what X and Y were. Kevin, Juan answered all 50 questions on the test. He earned 3 points for each question he answered correctly and lost 1 point for each question he answered incorrectly. His final test score was 102 points. The system of equations below describes the relationship between the number of questions he answered correctly, X, and the number he answered incorrectly. Part of the solution of the system is X equals 38. What does this value represent? What does that question represent, Kevin? All right, AJ. What does X equals 38 represent?
The questions he answered correctly.
Very good. Wow, that was easy. That was that. Next page. Jake bought X pairs of thermal socks and Y shirts at the department store. He spent a total of $80. The following equation describes the relationship between the number of pairs of thermal socks and the number of shirts he purchased. 11X plus 18Y equals 80. It says the order pair 4, 2 is the solution of the equation. What does 4, 2 represent? Well, 4 is my X, and 2 is my Y. It says right up here, X is the pairs of thermal socks. Y was shirts. So, shirts cost $2. That's a no. Because there is no 2 in the problem. It says, all right, it says 2 for shirts. Doesn't mean shirts cost 2 times as much as the socks. Then B says Jake purchased 4 pairs of socks. Okay, I like that. And 2 shirts. I think that's it. It says socks cost $4 each and shirts cost $2 each. Well, that wouldn't make sense. Why would socks cost more than shirts? And Jake spent $4 on socks and $2 on shirts. That doesn't make sense. Delaney, Francisco purchased X hot dogs and Y hamburgers at a baseball game. He spent a total of $10. The equation below describes the relationship between the number of hot dogs and the number of hamburgers purchased. 3x plus 4y equals 10. The ordered pair 2, 1 is a solution of the equation. What does the solution represent? Well, up here it says hot dogs and right here it says Y is hamburgers. So Delaney, what does 2, 1 represent?
Two hot dogs purchased and 1 hamburger.
Very good. Now we can think about this in actual context. Where does a hot dog, or would a hot dog ever cost more than a hamburger? And the answer is no. Like in my life, I've never seen a hot dog cost more than a hamburger. So that means C's out. And then D says Francisco spent $2 on hot dogs and $1 on hamburgers. Well, no, he spent $10. So that would be $3. And then hamburgers don't cost 2 times as much as a hot dog. Okay? So it was definitely B. Nicely done, Delaney.
Mr. Harmon,
Yes.
Hope's connection's really bad and she can't hear anything. So she's
Okay.
cut off. I think she's
Okay,
cut
thank you for letting me know.
off. Welcome.
Just in case you guys have problems, I do post them on Schoology almost daily. Sometimes it takes a little longer for them to load up. At the theater, Fred purchased X popcorns and Y drinks. All right, he spent a total of $26. Okay. The equation below describes the relationship between the number of popcorns and the number of drinks purchased. The ordered pair 5, 2, so let me write that, 5, 2. All right, represents the solution of the equation. What does 5, 2 represent? X is popcorn. 2 is drinks. So, Mackenzie, what does 5, 2 represent once I labeled it?
Fred purchased 5 popcorn and 2 drinks.
There it is. So whenever you have an ordered pair, the most important thing is to label it, to know what you're talking about. Any questions? All right, so we're going to move right into 1, 3. And we're just going to do a little bit of this, okay? And we'll see where it goes. So 1, 3 is solving equations with variables on both sides. So here's the issue with variables on both sides. I can now have kind of like 3 different types of answers that come up. The first one we all know. It's like x equals a number, y equals a number, a equals a number. We get a solution. But now when I have variables on both sides, that doesn't always happen to be the case. The case might be that all my variables go away. What if I have the same number of variables on both sides? Well, if that happens, I can get one of 2 answers if the variables completely go away. I could either get no solution, which is like you get 10 equals 12. That's not true. That's no solution. Or you could get something like 10 equals 10. When that happens, that's called infinite solution. So right now we have 3 different answers that we could get. All right. But we're starting out, so we're just going to do a few that we get an answer, and then later on we'll get into ones that have no answer or infinite solution. So when I'm solving equations with variables on both sides, the first thing I do is I identify the smaller variable. What do I mean by smaller? Well, I have 3k and 8k. Well, 3 is smaller than 8, so I'm going to focus on getting rid of the 3. So I get rid of a positive 3k by subtracting it. And the reason I do this is I want to end up with dealing with positive variables. Now, could I move the 8k? Absolutely. Absolutely, Neve. I can move the 8k. But the problem is when I move the 8k, I'm going to get a negative 5k. And that means I'm going to be dividing by a negative. And my personal experience is when kids and adults are dealing with negatives, they tend to make more mistakes. So I like to deal with positives. Now I have 45 equals 5k plus 25. So I subtract 25, just like I did yesterday. And I have 20 equals 5k. And then you divide by 5 to get k equals 4. And of course, I could check my answer by plugging it back in. I could do 3 times 4, that's 12, plus 45, that's 57. 8 times 4 is 32, plus 25 is 57. So I knew I got my first problem right. Now here with B, I have 5x and a 7x. The 5x is smaller, so I'm going to move that. And I'm going to move it by following inverse operations. It's a positive 5x, so I subtract 5. So I get negative 1 equals 2x plus 5. Now, Drew, I need to get rid of a positive 5, so I subtract it. And that gives me negative 6 equals 2x. Ran out of room, so let me rewrite that. All right, Chris, to get rid of 2 in front of the x, I divide by it, and I get negative 3 equals x. And just like the last one, I could always plug it back in just to see if I got it right. And I would do 5 times negative 3 is negative 15, minus 1 is negative 16. And then I could do 7 times negative 3, well, that's negative 21, plus 5 is negative 16. Miss Kender, can you hear me?
Yeah.
Which z is smaller, negative 5z or positive 5z? Which one's smaller?
Negative 5z.
Very good. So to get rid of negative 5z, I add 5z. That gives me 7 equals 17 plus 10z. Now what would you do, Miss Kender?
You would subtract 17 from 7.
Absolutely. So you have 10z equals negative 10. And the last step, what do you got?
Divide by 10.
Divide by 10. When we divide by 10, we get negative 1 equals z. Now, my advice to you is get comfortable with working with variables on both sides of the equation, the left or the right. It doesn't really matter. Negative 1 equals z or z equals negative 1. They're both fine to me. Andrew Ballard.
Yeah.
What would you do for D?
Add 4 to both sides.
Okay, now this is a problem where what I told you a second ago kind of makes this problem longer. What Andrew's saying is like, he's like, listen, I'm cool with dealing with the negative at times, okay? So I'm gonna move that 4x and just realize I'm gonna have to divide by a negative and be careful about that. Now, the way I just said it was, I would actually move the 9x and move it over to the 4x. But I want to show you that you can do it either way. So Andrew said to add that 4x, because that's going to get all of my variables to one side very quickly. So now notice, after doing that, I just have to divide by a negative 5 to get my answer. Nicely done. Neve. You there, Neve?
Yeah, I'm here.
What would you do in E? E is big, it's ugly, it's got a lot of crazy stuff going on. But if we do it like a step at a time, I think we can answer this. So what would your first step be?
My first step would be multiply the things in the parentheses by the numbers outside of it.
Yeah, do you remember what that's called, by the way? You're right. What's it called? Starts with a D.
I can't.
That rhymes with distribute.
Distribute.
Yeah, there you go. So Neve said distribute that 3 on the left, so I get 9x minus 12. And on the right, I'm going to do 1/4 times 32. Well, I'm not a big calculator guy, so this is how I do distributing fractions. I do 1 times 32, that's 32, divided by 4 is 8. 1 times 56 is 56, divided by 4 is 14. Now, this problem looks just like B, okay? So I'm going to go ahead and I'm going to subtract 8x from both sides. I'm going to get x minus 12 equals 14. And then I add that 12. And I get x equals 26. Any questions? All right.